Today we're going to be looking at box and whisker plots. So you can see here's the state standard that this goes along with, and here's the success criteria. So you need to be able to make a box and whisker plot to represent data sets. You want to be able to interpret a box and whisker plot, use box and whisker plots to compare data sets, and explain how to identify outliers in a data set. All right, here's some important information on box and whisker plot. You can see right here what a box and whisker plot is going to look like. There are some important values that you need to know. Your median is your Q2, okay? Your Q2 is your median. And then you've got your first quartile, that's Q1. And then your Q3 is your third quartile. And then anything that is outside of that would be your outliers. So your least value and your greatest value. And that's why they call it a box and whisker plot, because you can see these little outliers sometimes make it look like it has whiskers. So make sure that you know what information that comes from a box and whisker plot. Some vocab that you need to know. A box and whisker plot shows the variability of a data set along a number line using the least value, the greatest value, and the quartiles of the data. So again, from the previous page, remember it had the Q2 in the middle, that was the median, and then the Q1 and Q3 is the two ends of the box, and then you had your outliers outside of that. So make sure that you know the least value and the greatest value and the quartiles of the data. Your quartiles divides the data set into 4 equal parts. The median, your second quartile, Q2, divides the data set into 2 halves. The median of the lower half is Q1, and the median of the upper half is Q3. All right, so remember median is the middle number. So you're not taking the average, you're just lining the numbers up in order and taking the middle number. That's your median. 5-number summary, the 5 numbers that make up a box and whisker plot are called the 5-number summary of the data set. And your IQR, often you'll see this as IQR, that's your inner quartile range, is the difference of the third quartile and the first quartile. So basically IQR equals Q3 minus Q1, the difference, Q3 minus Q1. Example 1, making a box and whisker plot. So this one says make a box and whisker plot that represents the ages of the members of a backpacking expedition. All right, so the first thing we need to do is order these from least to greatest. So if you look over through here, the number that is the least is 18. So let's put it first. Because again, we have to find the median, and the median comes from the middle number when it's least to greatest. So 18. The next smallest number is going to be 22. And there's 2 of those. And the next number is 24. And then we've got 25 shows up 3 times. And then the next largest number would be 27. And then 28. And then we have 30 3 times. And that is all of our numbers ordered from least to greatest. All right, so then we're going to draw a number line that includes the least values to the greatest values. So let's see if we have a number line. We're going to have a number line from 18 up through 30. And I can even go one past there. Doesn't matter, but at least includes all the numbers from our data set. All right. Sorry, my number line is kind of going downhill, but hopefully you can read this for what it's supposed to be. All right, now after we have a number line, we're going to put the points for our 5-number summary on here. So first thing let's do is we're going to find the median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 numbers means we have to take the middle of the two numbers. I mean the middle. Since it's an even number, we got to take the average of the middle. So we're going to go 1, 2, 3, 4, 5, 6. And it's going to be 25. So 25 is going to be our Q2. So we can say this is going to be the middle of our box. So you can see up here the median. Here's the picture that we're getting ready to draw. Ours is going to be based on the data we have. This is in general. All right, I'm going to move this down a little bit. All right, so here's the center. This is my Q2. All right, now we need to find the median of the first half and the second half, and that gives us our Q1 and our Q3. So, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to go, the middle of here would be between 22 and 24. And what comes between 22 and 24 is 23. So this is going to be our Q1. We found Q2 first. Now we've got to find Q3. So Q3 is going to be the middle of these 6 here, the middle of, or the median of the top quartile. So 1, 2, 3, so between 28 and 30. So we know 29 is going to be our Q3. All right, so very rough drawing here, but you can see that is our box part. Now we need to do the least value, which is 18. And I'm looking at my number line here. You can see that 18 is on my number line, so that's going to be this whisker. And then 30 is the highest number, so that's going to be the upper whisker. And that's how you draw a box and whisker plot based on a set of data. Find the median of the middle, find Q2 first, then find the median of the first half, and find the median of the second half, and then add your least and greatest values. And that again is called the 5-number summary. 1, 2, 3, 4, 5. That 5 numbers makes up that data set. And a study tip for you, sometimes the first quartile is called the lower quartile, and the third quartile is called the upper quartile. And I probably did refer to that as well. Example 2. Now we're going to interpret a box and whisker plot. All right, so the box and whisker plot represents the lengths in seconds of the songs played by a rock band at a concert. All right, so this time it gives us the information in a box and whisker plot. So we got to find and interpret the range of the data set. Okay, so remember the range is the difference from the highest to the lowest value. So if you look here, you can see the lowest value is 160 and the highest is 300. So we can say 300 minus 160 equals 140. And again, this represents seconds. So that means that the song lengths vary no more than 140 seconds. All right, so then it says describe the distribution of the data. So if we look at the box and whisker plot, what do we notice? So each whisker represents 25% of the data. So you can see that this whisker represents 25% and this represents 25%. How do we know that? because this number comes from the median of this half, and this number comes from the median of this half. All right, so we know that 25% of the song lengths are between 160 and 220. So we can see 160 and 220. So we know that 25% lands here. We know that another 50% is between 220 and 280. So we know 50% falls in this category here. And we know that there's another 25% from 280 to 300. So we can say 25% from 160 to 220. And we know 50% falls between 220 and 280. And we know another 25% falls in the upper quartile, which is 280 to 300. All right, now it says, find and interpret the inner quartile range of the data. So remember, the inner quartile range is Q3 minus Q1. It's the difference between Q3 and Q1. So if we want to find and interpret that, let's come down here and say C part. So the inner quartile range is going to be Q All right, so inner quartile range, Q3 minus Q1. So for this data, we can see that's 280 minus 220. So we've got 280 minus 220, which equals 60. So our inner quartile range is 60. All right, and the last question says, are the data more spread out below Q1 or above Q3? So if you look at it, you can see that the length of this whisker is longer. So you know that the data here is more spread out than the data here is more closer together on the number line. So you can say that Q1, so D part, Q1 is more spread out. And again, that's just based on looking at the graph. You can see how much more this is spread out because this is 60, 80, 200. This is going by an even scale. So these numbers here are going by 20s all the way across. So that means this is a longer distance than this. And that's how you can tell that the data is more spread out.